Hello guys. So you might have all done yesterday's problem of the day, and if not, or you might have some issues with it, it will all be solved in this video. So without any further ado, let's start with the LeetCode and GFG yesterday's problem of the day. So let's start with the LeetCode problem. So the problem is continuous array, and the problem statement it is given a binary array nums, return the maximum length of a contiguous subarray with an equal number of 0 and 1s. So you will be given an array of zeros and ones, and you have to find the maximum length of subarray with equal number of zeros and one. So these are the provided two example which are nums with 0 and 1. So in this we only have 1 0 and 1 1 1, and they both are equal. So the length of the subarray is 2. In the example number 2, we have 2 0 and 1 1s. So it will only form a one subarray of 1 0 and 1 1, and other can be a subarray of 1 1 and 1 0. So the length of the subarray is 2. I also provided an example to help you understand how it will work. So this is also an example provided. So in this, the length of the subarray is maximum length of the subarray is 12. It is 6 with 6 0 and 6 ones as highlighted in this example. So one approach could be trying to solve it using brute force. So the brute force approach will be we will start iterating from I equal to 0 till n, and inside it there will be another for loop with j equal to I to n. So the code goes around like this. We will start from I equal to 0, and we will initialize two variable ones and 0, and we will start the inner for loop with j equal to I to n. Now, at any point, if we get an one, we will increment the one's value, and if else we will increment the zero value. And if the length, if both the zeros and one are equal, then we will then update our result as math of max of result comma j minus I plus one. So suppose I equal to I is zero, I is pointing to zero value, and j is pointing to I is pointing to zeroth value, and j is pointing to suppose let's say 0, 1, 2, 3. J is pointing to third value. So the result will be updated at j, which is 3, minus I, which is 0. So 3 minus 0 is 3 plus 1. So the length of the so the result will be updated to 4. Result will be updated to 4. So in this way, we could solve this problem, but it will be a brute force approach, which could definitely give a time limit exceeded error, because the constraints provided to us are between 1 to 10 raised to 5. Hence, so this will be an time limited exceeded approach, because 10 raised to 5, which will be outer loop, which is from I equal to 0 to n, and 10 raised to 5, which is an inner loop, which is j equal to I to n. So so after calculation, this will be 10 raised to 5 plus 5, which will be 10 raised to 10, which is definitely greater than 10 raised to 8. So it will give a 10 TLE approach. So a better approach could be using a mathematical concept, which is if a number is repeated again, if in a given array a number is repeated again by doing some calculations between the numbers, we are sure that the number between the first occurrence of that number and second occurrence of that number, the number between them are definitely giving us zero. Hence, the number is getting repeated. Uh, so let's take an example of, let's suppose we have a 2, 3 and a minus 3, and suppose let's say a 4. So here it will be 2, which will be sum will be 2. Then after that sum will be 5, and after that by 5 minus 3 is 2. So the sum is 2, which is repeating again. So it is sure that the 3 minus 3 is giving us 0. So 2 is repeated again. So we can use this concept uh, to max to minimize the time limit of our approach. So what we will do in this case is let's say we don't have any number to get subtracted to get a zero. So what we will do is for every zero we will update the value to -1 in the array. So zero will be -1 and one will be one. So in this example, let's take this example 0 1 1 double 0 and triple one. And after updating value to 0 to -1, this will be our array. So and to find a number which is repeated again at a certain index, we will use a map which will give us a result in a big of one. So it will not affect our approach and it will not give a TLE. So suppose let's iterate this, or let's try run this example. So at 0 we are getting a -1, which is updating to the sum will be -1, and in a hash map provided -1 is 0. Uh, after that the one after that the one is after that I will get incremented to 1, and this our sum will be 0 because 1 minus 1 plus 1 is 0. Hence we are sure that it is again giving us 0, or it is giving us 0, and we are sure that there is a number which is giving us 0 to a certain extent. Because so yeah, at a certain point we get 0, then we are sure that we have a sub array of 0 and 1 with equal number of 0 and 1. So, hence we will at the start we can also do that in our hash map. We can we can put a 0. We can at the start of our hash map, start of our code. We can what we can do is we can put 0 as -1 because we know that we have a 0 with us. As we will we set our 0 to -1 in our map. And hence minus. So starting with the approach again. At a 0 we got a -1 which we updated to 1 in our map, and in at 1 we got a 0. So hence what we will get at some we got a 0. So hence what we will do is we will find that 0 in our hash map which is -1, and we will update our result as one I, which is the our I now is at one position. So 1 minus 1, which is 2. So result will get updated to 2. Hence we know that so this which is our sub which get updated. So after that I will be incremented to 2. So I equal to 2, which the sum will be 1. So as 1 is not encountered in our map, so we will just append it to our map update and put it its value. So I is 2. After that, the sum will become after the I will increment to 3, and our sum will be 0. So as the sum is 0 and we found a 0 in our hash map, we know that there is somewhere with equal number of zeros and 1. So we will update our result that I equal to so I is at value 3. So 3, and we will get 0 value as minus of 3 minus of 3 is 3 minus of 1 is 4. So this will be our updated value, which is the updated sub array, which is of result 4. Then we will increment the value I as 4, and we got the value at -1. So our sum will be -1. As we are getting a sum as -1 at 0, then we know that so -1 is also -1 is getting repeated. So we know that there are certain numbers which are getting this which are getting after some operation to 0, and we are getting repeated this number. So as -1 we found -1 at 0. So the total number of array in this will be double 0 and double 1. So because we are getting 0 at -1, so it is repeated. So we are hence we are getting the 0 the required subarray as double one and double zero. So in this case, our map will found our map will found at minus one is a zero, and our I is at four. So four minus of zero is four. So the result will get updated to four, and hence we found our answer, required answer. So in the next case, the I will get incremented to five. So as I is incremented to five, the we are getting again as zero, and we found the answer at zero. So in this case, we know that zero is getting repeated if it is in map. So it will be the so our result will be updated to I is at five. Five minus of my five minus of minus one is six. So our result will be uh, from this to this. Uh, Zero double one double one double zero double one. So our result will get updated to four. So result will get updated to six. Now the I will be incremented to six, and we will get a one. So in this case, we found that the one is at two, so it is getting repeated. So what will be how the result will get updated is max of six result, which is six, comma I is at six position. So six minus of minus six minus two, which is four. So result will be get six, because six is a greater number than four. So in this case, our sub array is this double one double zero. Now the I will get incremented to seven. The seven is two. So we are not getting any 2 in this case. So we will just increment it position at 7. So that's how we will find our result at 6. So so, re- as, so this is the core of this problem. So what we are doing in this case is we are getting the nums of length of the array in n for the nums array, if we are iterating over the nums array, and as we are getting nums of I equal to 0, we are updating its value to minus 1, or else we will update as else if we get a 1, we will just update its value to 1. Then I'm initializing a hash map here. It is particularly related to Java. In C++, it will be unordered map. And then I am yeah, then initializing two variables, sum is 0 and result is 0. And as I have said that we will at the start of the our iteration, we will put a 0 as minus 1. So this is the for loop which will iterate from I equal to 1 to n. So some will be some will get initializes to nums of I for in every iteration. And in the map, if we found that some, we will update our result as I have discussed, result comma I minus map dot get of sum, as we will put the required. Else if we don't find the required key, then we will just update its value to in the map, and at the end we will just return the result. So this will be a provided solution for this lead code problem of the day of day 16. So it will run in big O of n time. So the time complexity is this for loop is running in big O of n time. We are initializing in a map, therefore the space complexity is big O of n, and in this loop will run in big O of n time. And to find the key, it is a constant time which is big O of 1. As the time complexity of the solution is big O of n, and the space complexity is also big O of n. So without any further ado, let's start. So let's solve LeetCode GFG problem of the day of day 16. So the problem is delete without head pointer. It is an easy problem, and I do feel the same because there is only a trick in this problem. If you found out the trick, then it is an easy problem. It will be an easy problem. So the problem is you are given a node, delete node of a single linked list, where you have to delete a value of the given node from the linked list, but you are not given a head of the linked list. So in this case, we will given a linked list. We will only provide the node which is getting deleted, and we will not be provided a head of the linked list. The condition is by deleting the node value, we do not mean removing from the memory. So we don't have to remove from the memory by using delete keyword in C++ particularly. we just have to remove the link or remove the link of the node. The condition is we when the value of the given node should does not exist in the linked list, then the number of nodes in the linked list should decrease by one. Okay, that's fine. All the value before and after the delete node should be in the same order. So there's some certain node provided which are helpful to us. Multiple node can have the same value as delete node, but you must try only remove the node whose pointer delete node is given to. It is guaranteed that exists a node with a value equal to delete node value. It will not be the last node on a linked list. So the provided delete node will never be a last node on a linked list, which is a really big node to consider. So so this is so let's take the example of this linked list. The certain values are 10, then 24, and 30, and the delete node is our 20, which is appending, which is pointing to it. So, what we can do in this case is we are not towards the head of the linked list, and we knew that it will never be a enter, it will never be a last node of the linked list. So, what we can do in this case is, as the linked node provided, what we can do is we can just copy the value of the next. There is a delete node here. So, what we can do is we can copy the value of the next node to this node, to the delete node. So in this case, it will be find it is removed, but it is still in the memory. The node is still in the memory. So by copying its value, what we can do is we can remove the link of this pointer, remove the link between the delete node and the next node, and uh, we can we can just remove the link and append its link to the next of this next node. So in this case, our linked list will be 10, then 4, and then it will be 13. So it will be as if the node is deleted, as the node does not exist in the linked list. So it is an it is an easy problem with just two lines of code. So what we will do is delete node.data as the delete node is provided by. So here the delete node is provided by the GFG enter. So what we will do is and our delete node is 20. So what we will do is delete node to data, which is 20. It will be equal to delete node to next node data. Delete node dot next dot data, which is 4. In this case, you can see it is 4. The next operation will be delete node dot next, which is equal to delete node dot next dot next. Delete node dot next, which is equal to delete node dot next dot next. So the link will be of this 4 and it will be 30, and the link between 20 and 20 node and 4th node is removed. So, let's start submitting this problem. So as you can see, it is getting submitted and all the test cases are passed. So, let's talk about time and space complexity. So time complexity is big O of 1 and space complexity is big O of 1. It's just we are doing two constant operation. So that will be it for the day. I hope you all have done the problems, and if you have find any issues, you can text me a message on the YouTube so that we can interact and try solving your problem. So that's it for today. I hope you all are. Thank you, guys.